Hello everyone and welcome to the NPTEL course in Pharmacognosy and Phytochemistry. In the previous sessions, we saw what are alkaloids and what are different classes of alkaloids and where all do they occur. From this session onwards, we will start discussing few examples of drug containing alkaloids. In this session, we will be seeing two drug containing alkaloids. One is opium and the other is belladonna. Opium is a narcotic drug chiefly known for containing compounds such as morphine, codeine and papaverine, whereas belladonna is a tropane alkaloid containing plant which is showing anticholinergic effect, and this contains compounds such as atropine, hyoscine and scopolamine. So let's learn their pharmacognosy. Opium is actually a latex. So it is a dried latex obtained from a plant called as Papaver somniferum, and this latex is generally obtained by making tiny incisions on unripe capsules of Papaver somniferum most commonly, or sometimes its variety Papaver album. Both of them belong to the family Papaveraceae. Now going to the sources of opium, opium has been known as a narcotic substance from ages. In fact, there were even wars for opium. It is cultivated chiefly in Asia as well as a little bit in the African continent. If you go to see where all it occurs, it's chiefly cultivated in Turkey, Yugoslavia, India. In India, it is cultivated in Madhya Pradesh, especially the Neemach region, and in Uttar Pradesh. Apart from that, you will find cultivations of opium being done in Iran, Afghanistan, China, Burma, Pakistan, nowadays in Thailand, Russia, Tasmania and Laos. If you see the opium of commerce, now because this is narcotic and this is controlled substance, the famous places or the places where opium is chiefly controlled and grown is India, Turkey, Persia and Yugoslavia. So these are the main countries which are responsible for the trade of opium. Now going to the cultivation and collection. How do we collect opium or how is it prepared? Now if you see opium, we call it as the khaskhas or the khaskhas seeds. The seeds are very tiny or small. These are often mixed with sand or cultivated as such. They are generally sown in October or March, sometimes separated to protect the crops or sometimes sown all together. Now once that is done, the crop matures subsequently in June or July. Now during that stage you will see flowers and some capsules coming from the tree, coming from the plant. On an average, a plant will have 4 to 5 capsules. Now these capsules, once they achieve a golf ball size diameter about 4 to 5 centimeter, they start maturing and turning or changing in color from greenish to yellow. So during this time or just before this time, when they are greenish in coloration, what is done is a special tool bearing a very tiny needle like spikes, just less than a millimeter. This is called as nushtur. You can imagine it like a comb like tool wherein the needles are placed little apart from each other, and then this is used to make incisions. You can see here in this diagram the incisions are made, and the moment incisions are made, the latex starts flowing. Now one care is to be taken that this capsule is slightly hollow internally. So if this incisions go deep, the latex, instead of emanating outside the capsule, will go inside the capsule and get wasted. So carefully very tiny incisions are made and the latex emanates out. Now the timing here is very crucial. This is generally done in the afternoon period, during which the latex exudes out and then it subsequently collected. So now this latex is slightly milky, slightly fluid. the subsequent morning it almost dries up to a sticky residue. Initially it will be white or milky in coloration, but as it dries up you will see it turning little buff or brown. Okay, so next day when it is buff or brown, it's collected. Generally what is done is opium leaves are used, and this knife which is used to scrape it, they kind of paste it on it, and all this opium latex is pulled together. Now in some cases this latex doesn't dry completely, so what is done is the vessel is slightly tilted, so whatever liquid is still there in that latex flows out, and you get a much drier latex as compared to just keeping it in the vessel. One more thing is done is sometimes this latex is dried in shade, or sometimes even artificial heat nowadays is used for drying this latex. Once dried in the latex, it is closed in a butter paper or a grease free paper and packed in a weighed quantities. Why? Because this is a controlled substance, so every step is being watched out by the narcotics department, especially if it is done in India, and then the packing and everything happens right in front of officials. So if you go to see in the Indian scenario, the cultivation as well as collection and the processing of opium is controlled under the Narcotics, Drugs and the Psychotropic Substances Act of 1985. So apart from the capsules, nowadays even the opium poppy straw has been used to get morphine. Now if you see in terms of alkaloidal content, the capsule entirely contains about 0.5% alkaloids, but if you see only the latex component, the dried latex component, the dried latex is much richer in alkaloids. It contains almost 25% of alkaloids by weight, and of which 10% is of morphine alone. So let's see the chemical constituents. The most important compound which occurs in the latex is morphine. Now if you see in market, you will get 4 forms of opium, and you have to be very careful in analyzing that. One is raw opium. This is the one we discuss right now. That is, you take it from the plants, you weigh it and put it in a shield. So this is generally done for transportation purpose, and because it has been collected in the leaves, it contains vegetable debris, plant parts and dirt, and often fine particles are present in that. To get a better version of it, what is done is this raw opium is redissolved or resuspended in water, kind of made a clear solution. This clear solution is filtered through sieve, and then the filtrate is concentrated. Now because it is filtered through a sieve, all the vegetative debris is gone, and this form of opium is much purer. Later on what is done is this filtrate is taken and evaporated to get a concentrated latex. This is what is called as prepared opium. Now prepared opium is generally used for snuffing. Now once that is done, or once people smoke opium, whatever is left back of that is called as dross opium. So dross opium is basically a waste product after smoking of opium. The fourth category is important to us, and that is what is called as medicinal opium. For getting medicinal opium, what we do is we take the prepared opium. It is nicely made into a free flowing powder or granules by diluting it little bit with lactose. In the process, one care is to be taken that the morphine content of it should be between 9.5 to 10%. So dilute it with lactose, keep the morphine content between 9.5 to 10%, you get what is called as medicinal grade opium. In some cases, this opium is also de-aromatized or made less narcotic by extracting it with petroleum ether. They said that once you do this, the aromas lost as well as some narcotic substances are also extracted in the process, and it is much more richer in morphine. Now opium contains more than about 35 alkaloids which have been reported, and these alkaloids have been found in conjunction with meconic acid. In the previous sessions, we saw that alkaloids, owing to their alkaline nature, form association or form salts with acids. Now, this meconic acid is a marker of Papaver family and often found to be present in opium. So, people, if they want to check if it is genuine opium or no, they can either check for alkaloids or they can just check for the presence of meconic acid. In terms of appearance also, there's a little difference between the Indian and the Persian opium, Indian being a little more dark brown in color. Now, if you see in terms of contents, the morphine content goes from 10 to 16%, codeine little less, 0.8 to 2.5%, then is your narcotin, thebaine about 0.5 to 2%, noscapin 4 to 8%, narcine and papaverine goes to 0.5 to 2.5%. On the basis of the structure, you can divide alkaloids occurring in opium into different classes. The first one we saw is isoquinoline class. If you remember, isoquinoline so you can typically see this ring plus this ring here, that's an isoquinoline ring. So this carbon here, you can find the match is with this carbon here. So this is an isoquinoline ring, or sometimes it is also referred as phenanthrene for this reason. You can see A, B, C. If you take these three rings, they can be also called as phenanthrene. So morphine, you will find them being called as isoquinoline type of alkaloids or phenanthrene type of alkaloids. So in this we have morphine, codeine, thebaine, all are very much similar in structure, bearing, if you carefully see, morphine has hydroxy groups on both places. When you see one of this hydroxy groups replaced by a methoxy, you get codeine, and if both of these hydroxy groups are replaced by methoxy groups, you get thebaine. Apart from that, thebaine carries an additional unsaturation in this ring. So that's a little difference between your morphine, codeine and thebaine, and this property makes morphine more acidic or less basic as compared to thebaine, and this can be used as a way to extract morphine and to separate it from other alkaloids. Moving to the next category, you have phthalate type. Now you can see here, there's a phthalate group, or you have a phthalate isoquinoline. This is a phthalate isoquinoline group, and a good example of that is your narcotin. So you have your narcotin, you have your narcotoline, you have your noscapin, you have oxynarcotin, narcine, as well as 5-O-dimethyl narcotin. So these are examples which have phthalate group, which also have isoquinoline group which is being attached to it, and you can see there's an additional phthalate group as well. So you can call them as phthalate isoquinoline moiety. Now you also have benzyl isoquinoline. So here again you have isoquinoline, and here you have benzyl moiety. So you have phenanthrene isoquinoline, you have your phthalate isoquinoline, now you have your benzyl isoquinoline. A good example of that is your papaverine. Papaverine DL, that is both isomers of laudanine. You have laudanidine, you have codamine, and you have your laudanosine as examples of benz isoquinoline type. Then there are something called as a cryptopine type. So this is an example of cryptopine, and you can see here it's almost similar to isoquinoline, but this part is not joined. So cryptopine, you have two examples, protopine and cryptopine, and apart from that there are some miscellaneous classes such as aporenine, duodenine, meconidine, papaveramine, as well as lanthopine. So these are some of the alkaloids which occur in your opium, and that makes it very potent. How do you check them? What you can do is you can just quickly check them by doing few chemical tests. One thing you can check is for meconic acid. The next thing you can do is you can check for morphine. So, for meconic acid, you just take the aqueous extract of opium with a little amount of neutral ferric chloride solution. If it gives you a deep reddish purple coloration, now this reddish purple coloration is resistant to boiling. So, even after you boil it or you treat it with concentrated hydrochloric acid, the color shouldn't vanish. If the color doesn't vanish, that indicates that the meconic acid is present. For checking morphine, what we can do is you can just take a little bit of latex, and to that you add a little bit of concentrated H2SO4, that's sulfuric acid, and formaldehyde. If you get a dark purplish coloration, this indicates that your morphine is present. Now, opium, despite being a narcotic drug and a controlled substance, has numerous applications. So, opium is used as narcotic, analgesic, and sedative. Now, we have other mild non-narcotic or non-steroidal anti-inflammatory compounds, but in some cases when the pain is unbearable, take examples of cases when you have a trauma, accidents, or intense surgeries, or in terminal cases of cancers where the pain is unbearable. In that cases your morphine is prescribed. If giving morphine is not preferred, a little milder version, that's your codeine, is also been given. So, apart from that, it is also been used to treat a little cases of diarrhea, dysentery, and cough. Now, codeine is little mild sedative and has made its way to cough formulations. If you see noscapin is cough suppressant, but the good part is it's not narcotic. So, it acts as a central antitussive agent. Papaverine is a vasodilator. It is a smooth muscle relaxant, and it's often used to even cure your muscle spasms. Now, one thing to be noted is opium, especially morphine, is a controlled substance because it has a habit forming tendency. So, it causes addiction, and one derivative. So, just let me put it across. So, if you see your morphine, if you acetylate it, I'm just converting into acetyl. If you acetylate it, morphine gets converted into a narcotic substance called as heroin. And heroin, is a narcotic drug which has a very, very high tendency to form dependence. So, it's controlled substance, and that's the reason acetylation reagents such as acetic anhydride also have been controlled in market. Now, going on to the next example, we have belladonna, meaning beautiful lady, but a poisonous one. So, that's the reason it's called as deadly nightshade or death's herb or poison black cherry. The reason being, for people those who are attracted to the fruits of this, it bears beautiful cherry like but black color fruits. If you consume, they can be proven fatal. Now, this belladonna, the drug chiefly is dried leaves mostly, and in some cases the flowering tops of Atropa belladonna, the European one, or in some cases the Indian belladonna, also referred to as Atropa acuminata. Both of them belong to the family Solanaceae. Now, it contains somewhere between 0.3 to 0.6% alkaloids, but of that it should contain 0.35% of total alkaloids calculated as hyoscyamin. Geographically, it's found in US, Europe, as well as India, in some places of Canada as well. It's cultivated for its tropane alkaloids. This plant chiefly grows by sowing of the seeds, and this is done in summer. The reason this is done in summer is it is said that the plants or the seedlings which grow in summer with the vigor or with the heat have higher alkaloidal content as compared to the plants grown in other season. Now, these plants are tiny, they are just or achieve a maximum height of a meter or so, and then they bear beautiful purplish flowers generally facing downwards like a night lamp or a night shade, and they bear cherry like black color fruits which often attract animals, but because of its poisonous nature they are prone to be fatal. Now once the flowering season starts, what is done is the leaves as well as the flowering tops, you can harvest them from any age between 1 to 3 year old plants. This is done for maybe 2 to 3 times a year that the leaves are collected. Now once the plant is 4 years or plus, it is said that the alkaloid content is decreasing. So in that cases it is then dug up and thrown. Now once the leaves are collected, it has to be carefully dried, because if the moisture is present, it starts deteriorating the drug. We will see why it deteriorates, but once it deteriorates, you can easily detect that by presence of amine or ammonia like odor. Now the reason for its deterioration has something to do with structure. Now tropane alkaloids are actually esters. They are esters of alcohol called as tropinol. We saw this when we classified our alkaloids as tropane alkaloids. So you have one 5-membered ring, you have one 6-membered ring, and what they have in common is these 2 carbons and a nitrogen. So this tropinol forms ester with your tropic acid. Let's add it in this manner to form an ester, and this ester is called as atropine. Okay. Now atropine is when it is generally racemic in nature. There's no assignment in terms of optical activity. In some cases it's also referred to as 8-aza bicyclooctane nuclease, which has been joined to tropic acid. Now depending upon it, like I said, atropine is a racemic mixture. So you have your tropine, tropate in the both racemic plus minus form referred to as atropine. Hyoscyamin is specifically negative in terms of its optical activity. So you can see here. Now the plant, if you see the limits, contains 0.35% hyoscyamin. It is said that the atropine is almost negligible in the plant at initial stages, but as the plant dies and is extracted, racemization occurs and more of this hyoscyamin is getting converted into atropine, and that's where your atropine is found. In addition to that, you have one more alkaloid which is also predominant in this plant, and that is hyoscine. Hyoscine is generally epoxide of hyoscyamin. So at this position, if you attach epoxide, you get what is called as scopolamine. The interesting part about scopolamine is it has the ability to permeate the blood-brain barrier easily, and as a result has more predominant CNS effect as compared to your atropine. So if you see the summary of alkaloids present, it contains 0.3 to 1% alkaloids, predominantly L-hyoscyamin, and atropine. You have apoatropine. Now apoatropine is, instead of CH2OH, when this hydroxy is lost, you get a double bond out here. So that's your apoatropine. Belladonnine, you have cuscohygrine, you have crisatropic acid, atrocin, leucotropic acid, you have N-methylpyrrolin, you have homatropin. Apart from alkaloids, this plant is rich in flavonoids such as rutin and glycosides of camphorol such as camphorol 3-ramnoglucoside and 7-glucoside. Then you have quercetin 7-glucoside. Atropine, like I said, is generally formed by racemization. During the extraction process, it's predominantly L-hyoscyamin which is present. Now you can check the presence of tropane alkaloids by a very specific test which is called as Vitelli-Morin test. Now if you take your tropane alkaloids or extract enriched in tropane alkaloids completely dried, and if you treat it with fuming nitric acid, completely evaporated by heating it, and then whatever residue you get, dissolve it in acetone. to that, if you just add an alkali like an alcoholic potassium hydroxide solution, you will get a violet coloration. That's a very specific test for tropane alkaloids. Apart from that, if you have pure alkaloid, you could also perform a Gerard's test, which is you can take the alkaloids and take a 2% solution of mercury chloride in ethanol. If it gives you a red color, it's mostly atropine. If it gives you a red color but only after much heating, it's good chance it's a hyoscyamin. And if it is a white color precipitate that you're getting on reacting it, it's basically hyoscine. Now, one more test has been used to check. It was used earlier in patients to see if they've been poisoned by belladonna. How do you do that is you take the extract or you take the medicine or whatever you want to test which you feel contain the alkaloids. You take an alcohol or dissolve that solution in alcohol. Now to this alcoholic solution you add your ammonia. In presence of ammonia, if you are seeing a blue color fluorescence, it's a good indicator that it's a belladonna poisoning, and that is specifically for detection of your scopolamine. In terms of applications, belladonna shows anticholinergic effects. So it blocks the muscarinic cholinergic receptors, and as a result it gives you what is called as narcotic, sedative, diuretic, mydriatic effects. Now it is used as a anodyne, a little bit of painkiller, and also it dries up the mucus. So if you want to check on the secretion, you want to dry the mucus, you can use your atropine. Now it is used to relieve spasms because it's a smooth muscle relaxant of the gut as well as of the respiratory tracts. Now as it dries up the secretion, it is also used to control excessive perspirations in cases of tuberculosis when people sweat a lot. If you want to control that, in some cases atropine is given. Now it is also given as adjunct in treatment for peptic ulcers or in digestive disorders, ulcerative colitis or diarrhea, where especially your gut is inflamed and you need a little gut relaxation. Apart from that, belladonna is also reported to a very good extent to act as a parasympathetic depressant. So these are few applications of atropa, and even in the purest form, as you can see, atropine is also been administered to the patient and is used in therapeutics. Here are a few references to read more about these topics, and thank you everyone for your patient listening.